Hello students, welcome to IIT and Git classes. Today we will discuss the questions from engineering mechanics that has appeared in GATE 2021 mechanical question papers, both in the morning and afternoon papers. So in total there were 4 questions. Out of these 4 questions, one question is from Truss, that is easy in nature. We will consider it to be easy, right? 2 questions where I will say they will be in easy to moderate range, and one question from rotational motion is in the category of moderate to hard. Okay, so let us start. Let us discuss all the questions. Okay, this is the first question. What does this question say? It says two smooth identical spheres, each of radius 125 mm and weight 100 Newton, rest in a horizontal channel having vertical walls. The distance between the walls of the channel is 400 mm. Okay, so they are talking about two spheres, right? They are talking about two spheres, identical spheres. What is the radius? Radius is 125 mm, right? This is the radius, 125 mm, and the distance between the vertical walls, right? These two are the vertical walls they are considering. What is the distance between the vertical walls? 400 mm. Right, the reaction at the point of contact. So here it is here where you have to find out the reaction. Point of contact between the two spheres is dash Newton. Round off to 1 decimal place. Okay, so now what is the step to solve this kind of problems? The first step to solve any mechanics problem is drawing the FBD. Right, so let us start with drawing the FBD. Right, so this is the kind of FBD. Okay, I accept that in FBD we don't show the surrounding, but for the simplicity, for us to understand properly, I have shown it here. Okay, so what are the different point of contacts? You can see the point of contacts are, these are the point of contacts A, B, C, D, right? So there will be 4 reactions, RA, RB, RC, RD, as shown in the figure, right? Then the weight of the spheres, right? W downwards, vertically downwards. These are the all forces, right? What we need to require to find out, we need to find out RC. What is the value of RC, right? So we can take up any sphere you want. You can take up sphere number 1 or sphere number 2. I will prefer taking up sphere number 2 because the number of forces in sphere number 2 is 3. That is less than the number of forces in sphere number 1, right? So let us proceed with sphere number 2, right? But please understand, in this kind of question, right, when you are drawing the forces and finally how you will come up with the answer, either you have to apply the Lamy's theorem, or if there are 3 forces, yes, you can apply the Lamy's theorem, or you can resolve the forces and come to the answer, right? In any case, you will require the angle between the forces, and that is why to find out the angle, that is why the dimensions are given. Right, so how to find out the dimensions? Let us see how to find out the angle. So this is how you can calculate the dimensions, right? So the radius of the sphere is 125, so definitely this distance is going to be 250. Now this is given as 400, right? So if you see, this is 125 radius of sphere 1, this is 125 radius of sphere 2. So what is the distance, horizontal distance between the centers? It is 1 to 400 minus 250, that is 150, right? So if you have these two distances, we can definitely calculate the angle alpha. What is angle alpha? Angle alpha will come out to be 36.8698 degree. 36.8698 degree. Okay. Now the forces on the cylinder are not cylinder, sphere. It should be a sphere. It is a sphere. Okay, now the forces acting on sphere 2 are, we are talking about the sphere 2 because the number of forces are less, right? Now here I have solved it by Lamy's theorem. You can solve it by resolution of forces also. Please note that if you are using Lamy's theorem, all the forces should be arranged either radially outwards or radially inwards. That is why I have taken RC in this direction. You can see here, right? This is RD, this is RD. So I have shifted RD here. RC, this is the force RC on sphere 2, right? So I have shifted RC here, RC. I have just tried that all the forces are radially outwards. This is W. So these are the three forces, right? Only when you have arranged this radially outwards, or you can do it radially inwards also, then only the angles will be correct. So this is 90 degree, right? So you have to calculate this angle, let us see. Okay, now this alpha we have already calculated. So what is this? This is also alpha, vertically opposite angle, right? So what is this angle? Total angle is 90 plus alpha, right? 90 plus alpha, right? So what does Lamy's theorem say? Force divided by the angle opposite. So what is this angle? This angle is 90 degree. This angle is total angle is 90 degree, right? So RC divided by angle opposite to the force is 90. So RC divided by sine 90 is equal to W divided by sine of this angle, and this angle is 90 plus alpha. W divided by sine of 90 plus alpha. The value of W is already given in the equation. Let us see what is the value of W. Weight 100 Newton already given. The weight is 100 Newton. So substitute the value of W as 100 Newton, right? You will get the value of RC as 125 Newton. So the force of or you can say the reaction at the point of contact is 125 Newton. I hope it is clear to all of you. Okay, let us move on to the next question. This is the next question. Okay, what does it say? It says a block of negligible mass. So the mass of the block is very small, it is negligible, rests on a surface that is inclined at 30 degree. You can see the angle of inclination is 30 degree to the horizontal. There is a vertical force of 900 Newton and a horizontal force of 750 Newton, right? And the block is just about to slide. What does it mean? The block is just about to slide means this is a case of impending motion, or you can say it is a case of maximum static friction, right? The block is just about to slide, or you can say this is a case of limiting friction. Okay. Now, what you are asked, the coefficient of static friction between the block and the surface. You have been asked the coefficient of static friction, that is mu s. What is the value of mu s? That is, we have been asked. Round off to 2 decimal places. Okay. So first thing is drawing the FBD. Again, yes, we should not draw the surrounding, but okay, for better understanding, I have drawn it, right? Now, I don't know in which direction the block is about to move. It has just been said that it is just said that the block is about to slide, but I don't know in which direction the block is about to move. Is it going to move upwards or downwards? So just let us assume that it is moving downwards. Okay? Let us just assume that it is moving downwards. So if it is moving downward, if it has the tendency to move downwards, what will be the direction of force? This is the direction of force, friction force. The friction will be acting upwards, right? Okay. So normal reaction as always will be normal to both the surfaces in contact, right? Okay. So if you see the forces, properly, okay, these are the forces. If you see them properly, if you see them properly, 750, 900 friction force, right, and normal reaction. There are 4 forces. You are required to find out the friction force, coefficient of friction, right? Now we can resolve these forces 900 and 750. You can resolve the forces 900 and 750 Newton, right? When you can write friction force is equal to 900 sine 30. This angle is 30 degree. So the component of 900 Newton along this direction will be 900 sine 30, right? If you resolve this force, 900 force, if you resolve this 900 Newton force, it will be in 2 directions. One is this one, 900 sine 30, and one will be this one, 900 cos 30, right? Similarly, if you resolve the 750 force, right, one will be this in this direction, 750 sine 30, and one will be in this direction. This is 750 cos 30, right? Apart from this, the friction force is there, definitely the friction force in upward direction and normal reaction in this direction, right? So if you see if I want to find out the friction force, what is the friction force? What is the friction force? The friction force is equal to downward force is 900 sine 30 and upward force is 750 cos 30. So friction force is equal to 900 sine 30 minus 750 cos 30. If you evaluate it, it comes out to be minus 199.519 Newton. Right? What does the minus sign imply? The minus sign implies that the direction of friction force you have considered is actually wrong. The friction force will actually be acting in this direction. The friction force will actually act in this direction. Means the block has the tendency to move in upward direction. The block has a tendency to move in the upward direction. Okay. So it's just about the direction. So you have just neglected the minus sign. So we can say the F, the friction force is equal to 199.519 Newton in the downward direction, that is the southeast. Right. Again, what will be the normal force? The normal force is acting upward. Right. And what are the other forces? Right. There is a 900 cos 30 force acting downwards. So 900 cos 30 force which is acting downwards, right? And then there is a 750 sin 30 force acting downwards. So plus 750 sin 30. If you calculate this, the normal reaction end will come out to be 1154.4228 Newton. Okay. So now we know the maximum static friction. If you consider the static friction, maximum static friction, because the block is about to move, about to slide, it is case of impending motion, limiting friction, or you can say the case of maximum static friction. The friction that is acting on the block is the maximum static friction. And what is the value of maximum static friction? It can be said to be mu s into n. Substitute a value of F and n, you will get the value of mu as 0.1728. So you need to convert it into round it off to 2 decimal places. So what will be the value of mu? Mu is equal to 0.17. Answer. Okay, so this was the second question. Now let us move on to the third question. The third question is from plane truss, right? So it is a very easy question. Okay. So what is, you have given a plane truss PQRS, right? PQRS, where PQ is equal to RS, PQ is equal to RS, and angle PQR is equal to 90. PQR, this angle is 90 degree. Okay. The forces in the member PR and RS respectively are. So you have given 4 options. Okay. Now here in this question, just by observation, right, or you can say just by analytical analysis, you can say the forces in these 2 links will be 0. Right, the forces into these 2 links will be 0. Right, just by visual analysis. Why? Because we know when any 2 members are meeting at a joint, okay, when any 2 members are meeting at a joint, right, and there are no other forces, there are 2 members meeting at a joint and there are no other forces on that joint, or there are no other links, there are only 2 links, and apart from these 2 links there are no other forces, no reaction, no external load, right? In that case, the force in both the links will be equal to 0. Okay? The force in both the links will be equal to 0, right? We know that, right? I will not go into detail, okay? I will not go into detail, but definitely you can find out by resolution of forces, it will easily come out to be 0, right? So we know that force PQ equal to 0 and force QR equal to 0. So we are left with only 3 forces now. Force F, that is acting on the joint R, the force in the member PR, and force in the member RS. So let us draw the forces. Okay, this is the joint R, right? Force F is acting towards right. Now what will be the direction of force PR and RS? We can easily determine it by looking at the figure, right? How? For the net resultant, see, this truss must be in equilibrium. If the truss is in equilibrium, the joint R should also be in equilibrium. If the joint R is in equilibrium, okay, if the joint R is in equilibrium, all these forces should add up to 0. For these forces to add up to 0, these 3 forces should form a closed polygon, and a closed polygon is possible only in this way. This is the F, this is FRS, and this is FQR. FPR. So this is the only way possible, this is the only directions of forces possible. So using that concept, you can say that FPR will be acting downwards this way and FRS will be acting upwards. Okay, now it has become very simple, right? Already in question it is given that this and this is equal, this is 90 degree, right? And if you see properly, this is length L, this is length L. So this is a isosceles triangle. This angle is 45 degree. This angle is also 45 degree. So I have used that. Okay, this angle is 45 degree. Now you can simply resolve the forces. Okay, you can again use Lami's theorem here. You have to simply shift FRS here. From here, just you shift it here, right? FRS, and then you can use Lami's theorem. Okay, I have shown one question using Lami's theorem. So I am showing this question using resolution of forces. So if you resolve these forces, FPR sin 45, FPR can be resolved into two forces, FPR cos 45. So if you say summation of forces in x direction equal to 0, so FPR sin 45 is equal to F. So sin 45 is 1 by root 2. So FPR will become F root 2, right? Okay, we will talk about the direction, the nature of forces. Similarly, FRS, what is FRS? FRS is equal to FPR cos 45. There is one, if you take say summation of forces in y direction equal to 0, in upward direction it is FRS, in downward direction it is FPR cos 45, right? FPR is already F root 2 multiplied by 1 by root 2. So it is equal to F. Right. So how to find out what is the nature of forces? Very simple. Again, I will give you the trick, right? So any member, if it is pulling something, any member, anything which is pulling something will be under tension, and if you are pushing something, you will be under compression. If you are pulling something, you will be under tension, and if you are pushing something, you will be under compression. So if you see, this is the joint R. What is the member PR doing? The member PR is pulling the joint. So member PR, if it is pulling the joint R, the member itself will be under tension, right? And what is member RS doing? The member RS is pushing the joint R. So if the member RS is pushing the joint R, the member itself will be under compression, right? So the answer is B, F root 2 tensile and F compressive. In PR, it is F root 2 tensile, and in RS, it is F compressive. So this was your third question. Let us move on to the last question. Okay, this is a very nice question from rotational motion. Okay, similar kind of question have been asked, right? And this is just an advanced question from what have been already asked, right? It's a very nice question. So let us go through it. So what is given in the question? The wheels and axle system lying on a rough surface is shown in the figure. Each wheel has a diameter of 0.8 meter. Each wheel has a diameter of 0.8 meter, right? Means this is, okay, it is already given shown here, right? It is 0.8. Okay. And mass of 1 kg. So each wheel, there are two wheels, you can see there are two wheels, right? There are two wheels, this is a wheel, this is a wheel, and there is an axle, this is an axle, right? Both the wheels have mass of 1 kg, right? Assume that the mass of wheel is concentrated at the rim and neglect the mass of the spoke, right? So the mass of the wheel is to be assumed as if it is at the rim. It is at the rim. Mass of the wheel has to be assumed as if it is at the rim, right? Neglect the spoke. Why this has been done? So that you can calculate the moment of inertia easily, right? Rotational problems from rotational mechanics requires you to calculate moment of inertia, and so that you can calculate the moment of inertia easily, they have done this. Okay. The diameter of the axle is 0.2 meter. So this is the axle, you can see, this is the axle, right? This is the axle. What is the diameter of the axle? Diameter of the axle is 0.2 meter, and its mass is 1.5 kg. What is the mass of the axle? It is 1.5 kg. Neglect the moment of inertia of the axle. Okay, they have asked you to neglect the moment of inertia of axle also, right? And assume g is equal to 9.8 meter per second square. An effort of 10 Newton, on the axle in the horizontal direction shown at the midpoint. Okay, so you can see at the midspan of the axle, somewhere here at the midspan, right, of the axle, right, there is a force of horizontal force of 10 Newton. Assume that the wheel moves on a horizontal surface without any slip. There is no slip. This is case of pure rotation, right? The acceleration of the wheel axle system in horizontal direction is. So definitely you have to find out the acceleration, right? Okay. So now let us try to predict, before getting into the question, let us try to predict what should be the direction of the acceleration. There is only one force, external force acting, 10 Newton. Definitely, since it is a pure rolling case, there must be some friction. What will be the direction of friction? The direction of friction is definitely has to be opposite to the external load, yeah, right? So this will be the direction of friction, right? Now this friction, what can be the maximum value of friction? The maximum value of friction can go up to the external load, right? What is the external load? 10 Newton. So what can be the friction? Maximum value of friction can be, the maximum value of friction can be 10 Newton. It cannot be more than 10 Newton. In that case, if friction is 10 Newton, okay, there will be no acceleration. In general case, the friction force will be less than the external force, there is less than the 10 Newton, right? So if you see, there is a net force in this direction, there is a net force F net will be in this direction, because 10 Newton towards right and friction force which is smaller than 10 Newton towards left, right? So what will be the direction of acceleration? The direction of acceleration will be this. This is the direction of acceleration, right? If this is the direction of acceleration, how is the wheel moving? If this is the direction of acceleration, right, then how is the wheel moving? This is how the wheel must be moving. Right? This is case of pure rotation, no slip possible. So this is how the wheel must be moving. The wheel axle system, this is how it must be rotating. Okay. So if you see here, very easily can see that the friction force is actually helping the rotation. If you see very properly, the friction force is actually helping the rotation, whereas this external force, because the frictional force is providing a torque in the direction same as the acceleration, whereas the external force 10, it is providing a torque, it is providing a anti-clockwise torque, right? So it is providing a torque which is opposite to the direction of acceleration. Okay, all these concepts will be required while solving this, right? So let us do the first thing first. Let us try to draw the FBD, right? So this is the direction of acceleration, 10 Newton force acting on the axle, right? A weight mg, right? Friction force F acting down backwards. Okay, so what is the mass? Total mass will be 2 times mass of the wheel plus mass of the axle, right? What is the mass of wheel? 1. So 2 into 1 plus 1.5, that is total mass is 3.5 kg, right? This is a case of rotation. We will require to find out the moment of inertia. Let us try to find out the moment of inertia ahead. So what is the moment of inertia? See, you have to neglect the moment of inertia of axle. So what remains is the 2 wheels, and these 2 wheels you have to consider it as rings, because we are assuming all the mass to be concentrated at the periphery, right, at the rim, right? So they will behave, we can consider them to be ring. So what is the moment of inertia of rings? Moment of inertia of rings is equal to mr square, right? There are 2 wheels here, so it will be 2 mr square. So what is the moment of inertia about center of mass? 2 into mr square. There is 2 into mass. Whose mass? I am not talking now. We will not consider the total mass. We are just to consider the mass of individual wheel, right? Mass of individual wheel, that is 1 kg into r. What is r? The radius will be 0.4, right? The diameter is given as 0.8. So what will be the radius? 0.4. The radius of the wheel will be equal to 0.4 meter. So the moment of inertia is 0.32 kg meter square. Okay. Now what? Now let us move to forming the equations of motion, right? So first of all, we can apply the Newton's second law of motion. Net force is equal to mass into acceleration. So what is the net force here? 10 minus F is the net force. Acceleration is A. So you can write the net force, that is 10 minus F is equal to 3.5 A. The mass is 3.5, we have already calculated, right? For rotation, we can rewrite acceleration as alpha r. we have rewritten acceleration A as alpha r, right? So if you substitute the value of r, what is r? R is 0.4. So this equation becomes 10 minus f is equal to 1.4 alpha. Let me say this is equation number 1. Again we can write torque is equal to I alpha, right? Torque equal to I alpha. Okay, we are calculating the torque about the center of mass, so we are going to use the moment of inertia also about center of mass, right? So what is the total torque here, right? So if you see, the friction force is helping the rotation. As we have discussed, is in clockwise direction, right? So the friction force is also providing a torque in the clockwise direction. So I have written friction force torque because of friction force is positive, F into radius, that is 0.4, minus the torque because of the external load is negative because it is providing a torque, anti-clockwise torque. So 10 into the radius of the axle, right? The diameter of the axle was 0.2, so a radius of the axle is 0.1, 10 into 0.1, and since it is anti-clockwise, I have written it as minus, right, is equal to I alpha. We have calculated I 0.32 into alpha. If you rearrange the equation, it comes out to be 0.4 f minus 1 is equal to 0.32 alpha. If you solve equation 1 and 2, you will get the value of alpha as 3.409, right, 3.409. So what will be the acceleration? You have been asked what? Is it alpha or acceleration? The acceleration, right, to 1 decimal place. Acceleration to 1 decimal place, right? So the acceleration is equal to alpha in r. So alpha r comes out to be, what is the value of r? We have calculated r is equal to 0.4, right? So alpha r is equal to 1.3636 meter per second square. If you round it off to 1 decimal place, it will become 1.4 meter per second square. This is the answer. I hope all of you have understood all the 4 questions, right? Thank you all of you. Thank you.